Hello friends, this is Priyanka. Today we are going to solve a problem on hydroelectric power plant. In this video, the runoff data for two rivers, that is the river A and river B, is given and unit is million meter cube per month for a period of 12 months. Now if we observe this table, month starts from January and ends at December. And here is the runoff data for this river A and this is the runoff data for the river B. And we have to find out which river site is more preferable for the runoff plant as well as which river site is more preferable for the storage type of power plant, and we have to also give the reason for that. Now first I will read what is the given problem. First question: which site of river is more preferable for storage type plant and why? Second question: the ratio of runoff of river A and river B if constant runoff is required for 40% time of the year. Third question: if constant runoff is 80% time of total year is required, then mention which river site is more preferable for the runoff plant and why. Fourth question: at what percentage of time runoff rate of both rivers is same? So this was the given question. Let us first draw the hydrograph for these two rivers. Now here the period of 12 months is given. So on the horizontal line we have to plot the 12-month period and on vertical line we have to plot the discharge. If we observe the discharge for these two rivers, minimum discharge is 10 and maximum discharge, that is 140. So we have to take the range from 0 to 140. So we will take some suitable scale. So I will take 1 centimeter is equal to 10 million meter cube of discharge per month. So here 0, then we will take 1 centimeter distance, then 10, 20, 30, 40, 50, 60. So I have plotted the alternate numbers. So in this way, on this vertical line we have to plot the numbers from 0 to 140. Then on this horizontal line, this one gap, so it may be 2 centimeter or 3 centimeter, this one gap represents the period of 1 month. So for January month, from this 0 to first digit or this first vertical line, this gap is for the period of 1 month. Then here again the gap for the second month, third month and so on. So we have to plot here the 12-month period. Now if we observe, we will plot the hydrograph for river A first. So for this river A, we will refer this month as well as this runoff data. So here for the month of January, 40 million meter cube per month. So I will plot here for the whole month of January. That means this first plot I will make here one line for this 40 million meter cube per month. Then for this month of February it is 30. So for this 30 I will make here one line, that is middle point of this 20 and 40. Then next is 20. So for the month of March it is 20. Then April it is 15. So for the month of April I will plot here 15. So here is 0 to 10 and in between this 10 and 20 we have to plot here as a 15. Then again it is 10. After 10 it is 80. So we have to plot the line for 80. Then 140, 120. Then we have to move for 140. Then 120, then 100, 60, 50. So we will plot here as a 100, then 60, then 50, that is the middle point of 40 and 60, and then 40. Last month is 40. Now we will join this. So here this is the first line, so we have to join this with second line. Then So this is the hydrograph for river A. Now we will move for the river B. So I will draw this hydrograph with the help of dash line. Then first is 15. So we have to draw here one line. On second is also 50. So for this, it is in between 40 and 60. So I will draw this. Then 40, 40, 40. So 3 times 40 is there. So for the next 3 months we have to draw here line for this 40. So I will join this. Then 90, 100, 100. So next we have to move for 90. So that is, it is 90 is for June month. So we have to plot here. And after 90 it is 100, 100. So 2 months 100 is there. So I will join this line with this. Then 80, 70. So after that it is 80. So here is 80. And then it is 70. Then 60, 70. So again it is 60. And then again it is 70. So if we observe, this is the line in the form of dash is the hydrograph for the river B. So we will mention this. So we will mention this with the help of arrow, that is the hydrograph of river A and hydrograph of river B. Now we will move for the first question. So what is the first question? Which river site is more preferable for the storage type plant? So how to solve this question, and we have to give the reason also. Now for this question we have to first find out what is the average flow for this river A as well as river B. So how to find out the average flow for river A? So we will write here as a average flow for A and average flow for river B. So I will give you here, that is formula. So we have to add all these runoff data for the period of 12 months. For river A we will write here 40 plus 30 plus 20 plus 15 plus 10 plus 80 plus 140 plus 120 plus 100 plus 60 plus 50 plus 40, and divided by, we have to take the period. So period is for 12 months. So divided by 12. So if we add all these numbers divided by 12, then the average flow for river A is equal to 58.75. That is, unit is million meter cube per month. Now in the same way, average flow for river B. So we have to add all this data divided by 12, then it is 64.17 and unit is million meter cube per month. Now if we observe here, average flow for river B is more than river A. So which river site is more preferable for the storage type power plant? That is, river B is more preferable for the storage type power plant, and the reason is that average flow of river B is more than the average flow of river A. Now we will draw flow duration curve for river A as well as river B. So for that we have to make one table. So in the first row we have to mention the discharge in millions meter cube per month. So we will first draw the flow duration curve for the river A. So for that we have to arrange, or we can say rearrange, the given discharge in the question in descending order. That is, we have to take the highest discharge first, then we have to take the next lower discharge, that is 140, 120, 100, so on, up to the minimum discharge, that is 10. So we will rearrange this given discharge. Then the next row, that will be number of months during which flow is available. So regarding this given discharge, we have to write how many number of months this flow is available. So to fill this row, we have to refer this hydrograph and then we will write this row. Then the third row, we have to mention percentage time flow is available. So this third row is the calculation part. So with the reference of the second row, we have to calculate the percentage time for which flow is available. Now if we move for the second row, that is the number of months during which flow is available. So we will first take this 140 flow. So for this 140 flow, if we refer this hydrograph, then for river A, this 140 is available for 1 month. So I will write here as a 1. Then next is 120. So for 120, if we refer this, then 120 is available for a period of 2 months. Then next is 100. So if we observe 100, so for river A, it is available for the period of 3 months. Then next is 80. So for 80, here is the start and here is the end. 1, 2, 3, 4. That is 4. Then next is 60. So for 60, if we observe, this is the 1, 2, 3, 4 and this is 5. So here is 5 months. Then next is 50. So in between 40 and 60 there is 50. So if we observe here 1, 2, 3, 4, 5 and 6. So duration of 6 months. Then next is 40. So for this 40, if we observe, here are 2 parts. That is, in the first part 1 month is available. This flow is available. So this is 1 month and then we have to add this second, third, fourth, fifth, sixth, seventh and this is 8. Then next is 30. So in between 20 and 30, so here it is available. So if we observe from the start point, here 2 months are there because this is the first part, here this is the flow. Then for this 30, these 2 months plus 3, 4, 5, 6, 7, 8, 9. Now we will move for 20. So for 20, it is 1, 2, 3. 3 months. Then here is 4, 5, 6, 7, 8, 9, 10. Then we will move for 15. So for 15, if we observe, that is, it is in between 10 and 20. So here it is 1, 2, 3, 4. 4 months plus here is gap. So we have to remove that. That is 1, 2, 3, 4 and here is 5, 6, 7, 8, 9, 10, 11. And for 10 months, so if we observe all these total 12 months, this 10, that is the flow in millions meter cube per month, that is this 10 millions meter cube is available for all these 12 months. So we will write here as a 12. So in this way we have to refer the hydrograph and we have to fulfill this row. Then we will move for the next. So next part is the calculation part. So percentage time flow is available. Now this flow is available out of 12 months. So if we observe, I will write here, out of 12 months, this 140 flow is available for 1 month. Then out of 100, what is the percentage? So we will cross multiply this, that is 100 divided by 12. That is 8.33. Then in the same way, when 2 months is available, then out of 12 months, 2 months this flow is available. Then out of 100, what is the percentage? So 200 divided by 12. That is 16.66. Then for 3 months, we will follow the same procedure. That is 25. Then 400 divided by 12. That is 33.3. Then 500 divided by 12, that is 41.6. Then 600 divided by 12, that is 50. Then 800 divided by 12, 66.6. Then 900 divided by 12, that is 75. Then 1000 divided by 12, that is 83.3. Then 1100 divided by 12, 91.6. And here 100% because all the months the flow is available. So in this way this third row is also getting completed. Now we will move for this flow duration curve. So here we have to plot on this horizontal line percentage of time, and on vertical line we have to plot the discharge. So here is the discharge. So here minimum number is 10, maximum is 140. So we will plot here from 0 to 140. Now we will plot on the horizontal line percentage of time. So it is from 0 to 100%. So I will start from 0, then here 10, 20, 30, 40, 50, 60, 70, 80, 90 and last one is 100. Now we will plot the data. Here for the discharge of 140, we have to refer the percentage time. So for 140 discharge, what is the percentage of time? That is 8.33. So 8.33, that is it is before 10. So here we have to plot here one point for 8.33, that is approximately equal to 8, and on the line of this 140. So I will select here one point. In the same way we have to select the next point, 120, 16.6. So here middle point is 15, so after that it is 16, but discharge is 120. So I will plot here one point. Then 100, it is 25. So 25, that means in between 20 and 30. So for 100 I will plot here the middle point. Then for next is 80. So for 80 it is 33.3. So here is 80 and 33, that means after 30 we have to select the point. Then 60, 41.6. So here is 60, it is 41.6. Then 50, it is 50. So in between 40 and 60 it is 50. So for this 50, it is 50%. So we have to plot here one point. Then for 40, it is 66.6. So after 60, we have to plot, that is in between 60 and 70 it is 65. So after that we have to plot here 66. Then for 30 it is 75. So in between this 20 and 40 it is 30, and we have to plot here as a 75. Then for this 20 it is 83. So 20 it is 83. Then for 15 it is 91. And then here is 100. Now we have to join all these points. So this is the flow duration curve for the river A. In the same way, we have to plot the flow duration curve for the river B. So for that we will rearrange the discharge in the descending order. So highest is 100, then we have to plot 90, 80, 70, 60, 50 and 40. Now the second row we have to take the number of months during which flow is available. So for that we have to refer this hydrograph. If we observe for this 100 discharge, how many months it is available? So if we observe this dashed lines, then 2 months, period of 2 months it is available. Then for 90, that is for this 90 it is available for 1, 2, 3. So 3 months are available. Then for 80, if we observe here 1, 2, 3, 4. 4 months are available. Then for 70, it is 1, 2, 3, 4, 5, and here next section is also there, that is 6. So 6 months are available. Then again for 60, it is 1, 2, 3, 4, 5, 6, 7. So here 7 months. So we have to move up to end because here is also one line in the form of dash. Then we will move for 50. So for 50, if we observe, here is the first section, that is 1, 2. 2 months are there, plus here is 3, 4, 5, 6, 7, 8, 9. So 9 months. And for 40, again here 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10, 11 and 12. So 12 months are there. Now we will calculate the percentage time where the flow is available. So this is the months, number of months out of total months 12. So if we observe for this first column, then there are 2 months. So out of 12 months there are 2 months. So what is the percentage for this 100? So 12, here is 2, and for 100 here is question mark. So we have to cross multiply, that is 2 multiplied by 100 by 12, that is 200 by 12, that is 16.6. Now in the same way, when 3 months are there, then we can say that 100 multiplied by 3 divided by 12, that is 25. Then in the same way we will calculate the next percentage, that is for 4 months it is 33.3, then it is 50, then 58.3, 75 and 100. Now we will select here points. So I will select the points with the help of red marker. Now we have to refer this first row, that is the discharge and versus the percentage time. So for 100 discharge it is 16.6. So here it is in between 10 and 20 it is 15. So we have to plot the next point for this 100 discharge. Then for 90 it is 25. So for 90 it is 25. So we have to select the middle point. Then 80 it is 33.3. So for 80 again it is 33.3. Then for 70 it is 50. So here is 70. We have to plot here as a 50%. Then 60 it is 58.3. So here 58.3. Then 50 it is 75. So here is 50. We have to plot the point for 75. And then for 40 it is 100. Now we will join all these points. So this is the flow duration curve for the river B. Now we will move for the second question. We have to find out what is the ratio of river A and river B at 40% time of year. So here percentage of time is given. So we have to refer this flow duration curve. So from this flow duration curve, 40% of time, what is the flow for the river A? So it is more than 60, that is 61 million meter cube per month. And for river B, it is more than 70, that is 72 million meter cube per month. So we will take the ratio. So 72 is greater than this 61. So we will take ratio, that is the flow of river B divided by flow of river A, that is 72 by 61, that is 1.18. Now we will move for the third question. So third question is that flow of river A at 80% of time. So we have to find out which river site is preferable for the run of river plant for 80% of time. Flow is, minimum flow should be 80% of time. So we will first find out what is the flow of river A for 80% of time. So for 80% of time, flow of river A is more than 20, that is 23 million meter cube per month. And what is the flow of river B at 80% of time? So it is nearly 50, that is below than 50, that is 48 million meter cube per month. So how to find out which river site is preferable for run of plant? So for that we have to find out which river is having maximum flow. So if we compare the flow of river A and B at 80% of time, because 80% of time is the given condition in the question. So here flow of river B is more than river A, and that's why for run of plant river B is preferred. And what is the reason? That is the flow of river B is more than the river A. Now we will move for the fourth question. For the percentage time, for which percentage of time run of A and B is same. So we have to find out. So this is the run of river B and this is the run of river A. So which percentage of time it is same. So if we observe here the point of intersection, these two point of intersection. So for this point of intersection of river A and river B, percentage is 25%. and here is also point of intersection, and this for this point of intersection percentage is 33.3%. So percentage of time where the runoff of river A and B is same is 25% and 33.3%.